Good afternoon. I'm Yan Chengyi, and today I will be presenting on my final year project titled A Study on the Effect of Different LED Lighting on the Growth of Indoor Grown Plants, Vegetables or Herbs. The main function of a greenhouse is to control and monitor microclimate for the growth of plants, as well as to protect plants from harsh weathers. Microclimates such as temperature, humidity, and light intensity can be regulated in a greenhouse as those are the main parameters that will affect the growth of plants. The circular motion of the arrows show the cause and effect of the parameters. When the operating condition exceeds the stipulated or the values preset in the system, it will be regulated and integrated back to its normal condition. A perfect microclimate is vital as it will maximize crop production and improve the quality of plants. Lighting plays a big role in providing energy to the growth of plants. There are three types of light sources, which are sunlight, artificial lighting, and combination of both stated. As per reference to my project title, artificial lighting is studied and will be used in the construction of mini greenhouse. Pinho and Halonen mentioned that there will be an estimated population of 9.1 billion on Earth by year 2050. Hence, in order to fulfill the food demand, Food Agricultural Organization (FAO) states that the supply of food must be increased by 70%. There are several issues encountered by traditional farming methods, such as facing sudden depletion of natural resources, climate change, and natural disasters. Taking the most recent incident that had happened in India in the past few months as an example, this natural disaster has become one of the hot topics to be discussed during this pandemic, where the infestation of locusts has affected over 50,000 hectares of western India, and worse is yet to come as they predicted to have a second wave. The attack has caused crops to be totally destroyed, and many villagers had lost their source of income and has insufficient food supply. The solution to this issue stated above is by application of greenhouse in farming. As the application of LED lighting in greenhouse is not widely practiced yet and it has a limited number of resources, the lifespan of plants is remain unknown. Other than that, it is hard to control and prevent the invasion of small pests in mini greenhouse, as chemicals such as pesticides and herbicides are not used. Molding of roots is another major concern. To prevent it from happening, the amount of water supplied to the plant must be just enough, not too much nor too little. In order to set up the greenhouse system, numerous types of components are required. More research is needed to ensure the system to be working perfectly. The aim of the project is to study and produce a conducive and closed environment for the growth of plants. There are two objectives in this project. Firstly, it is to investigate the effect of LED lighting on plant growth, based on the LED type and wavelength. Secondly, it is carried out to evaluate if LED light source is able to replace sunlight to grow scallions in a mini greenhouse. Numerous parameters can be manipulated in a study of use of LEDs in a greenhouse: the size of LED, intensity of the light, type of LED, and so on. In this project, the effect of types of LED lighting on plant growth is investigated. Before building the greenhouse, a lot of research needs to be done on the type of LED to be used, the optimal conditions, the size of plant, and the type of plant to be planted. Limitations to this study would be the space constraint and unpredictable plant growth. The mini greenhouse should be portable and small. Hence, the plant chosen should be able to fit in the mini greenhouse. Furthermore, as plant is a living thing, its growth can be affected by a lot of factors including stress. Stress cannot be measured and it will affect the growth of plant. In the worst case scenario, it may even cause stunted growth in plants. The equation shown in the process of photosynthesis carried out by plants. Carbon dioxide is combined with water, and with the aid of light energy, they will be converted into carbohydrate, oxygen, and water. Carbohydrate produced is a source of energy for the plant. Chloroplast is an organelle in plant cell that absorbs light energy. There are three types of pigments in chloroplast. The most common pigment is a green-colored pigment named chlorophyll. It exists in most of our crops that are green in color. The second type of pigments are carotenoids. They range from yellowish to reddish color and are found mostly in carrots, orange, banana, pumpkin, and so on. Phycobilins are red and blue colored and are the most uncommon pigments. They can be found in red algae. Visible light spectrum consists of blue, green, and red lights with wavelength range of 400 to 500 nanometer, 500 to 600 nanometer, and 600 to 700 nanometer respectively. Any light with wavelength less than 400 nanometers is harmful to plants. On the other hand, lights exceeding 700 nanometer are called far red and they are commonly used to control flower blooming rate. Here is a fun fact. Have you ever wondered why vegetables are called greens? Well, maybe it's because of the color of the leaves. Then why do leaves appear green? Is it because they absorbed the green light spectrum? The answer is no. Pigments absorb green light the least. Hence, the color green is reflected to our eyes. In another word, green light has the lowest efficiency. Then why do plants need green light? Or what are the uses of green LED lighting in a greenhouse? It is because green light has the ability to penetrate below the canopy and provides light to the lower leaves to perform photosynthesis. Other than that, green LEDs are less harmful to human eyes as compared to other LED colors. Here are some pros and cons of using LED lighting in a greenhouse. One of the advantages is LED has a higher efficiency than high-pressure sodium HPS lamps. As shown in the figure, power supply to a LED bulb is mostly converted to light energy. Secondly, LEDs have a relatively low operational cost as the wattage and energy usage of LEDs are lower than HPS lamps. Thirdly, plants will have a better quality as they can be improved through selection of light spectrum. LEDs provide a more uniform light spectrum distribution as they are small, and thus, leaves below the canopy level will be able to get light source too. Lastly, LEDs are less harmful to plants as they release lower radiation heat than HPS lamps, as shown in the figure above. Disadvantages of LEDs are as such. LEDs have a limited coverage as they provide directional light beam. Other than that, the purchasing cost of LEDs are high, but in the long run, the maintenance and electricity costs will be able to surpass the purchasing cost. Blue LEDs are good for plants, but it's harmful to human eyes, as the long-term exposure to blue LEDs might cause retinal damages and blindness. Lastly, LEDs have an inconsistent light quality as they age, as the power might decline and fail to produce the expected light quality. Every plant has their own unique response towards different type of LED lighting. Some plants prefer blue, some red, and some green. It is all based on its necessity, state, and stage of growth. A research was carried out and it was noticed that most plants take a longer time to mature when LED grow lights are used. With respect to one of the scopes of study mentioned just now, the size of plant chosen is also one of the considerations to be taken. In the end, green onions, also known as scallions, is chosen to be the plant to be studied in this project. Research shows red LED is able to reduce its nitrate content and it takes about 40 to 50 days to mature, which is within the duration allocated for plantation in this project. Other than that, scallions have an average height and it does not require a deep soil bed and doesn't require a huge space because it can be sowed an inch deep with 18 inches between rows and 4 to 5 inches apart. IKEA soccer greenhouse is chosen as it is averagely sized and portable. It has a dimension of 45 cm by 22 cm with a height of 35 cm. As shown in the figure, it can be opened fully or partially. A chain is connected from the top flap to the metal bar of the greenhouse to limit the opening of the flap. The top right figure shows partially open flap with a metal rod acting as a stand to hold the flap in place. The video that I'm about to play shows that the greenhouse can be lifted easily so that the bottom tray can be washed and cleaned. The clear glass greenhouse will be covered with a black cloth as the objective of the project is to study whether green onions can grow in greenhouse which is fully operated with artificial lighting or not. Green onions prefer light, loose, and loamy soil with pH level of 6.5 to 7.0. Plantation of green onion is said to be easy as it can be planted in neutral soil. To enhance the growth rate, the optimal temperature for plantation is 20 to 30 degrees Celsius with a relative humidity of 70%. The soil should not be too wet because it might cause the roots to rot. There is an easy and common method to test the moisture content in the soil. It is called a finger test. Stick the finger up till the knuckle into the soil. Moist feeling indicates the water is sufficient and no extra watering is needed. However, if the soil feels dry, it should be watered. There are three plantation methods for green onion, which are by using seeds, sets, or transplants. Seeds are small onion bulbs that are half mature and have partially completed growth cycle. Transplants use 1 inch of the white area from the bulb or roots of the onion to plant. Method to be used in this project is transplanting as it has the highest success rate, said to be the easiest, and most recommended method out of the three mentioned. A planter box of 43 cm by 19 cm is used. 3 onions are to be planted to allow error or unexpected issues to happen. Furthermore, it will be easier to calculate an average value and to have a backup plan just in case one of them is unable to grow. With an assumed 5 cm diameter of onions, there will be a 10 cm gap between the onions. There are 6 major components used in this system to monitor the plant growth. DHT22, digital humidity and temperature sensor, 12-volt fan, Arduino Nano, RTC relay clock, ultrasonic and moisture sensor. The HT22 sensor is used to measure the temperature and humidity of the greenhouse. A 12-volt fan is used to control the humidity in the greenhouse. Arduino Nano is the control unit center of the system and it displays the necessary parameters of the greenhouse. Furthermore, RTC clock is used to control the LED lighting. Every plant has their own optimal daylight hours. With the RTC clock, the LEDs will be turned on and off automatically. Ultrasonic sensor is used to measure the water level in the water tank and sends a message to the control unit center if the level is too low. Moisture sensor is a probe inserted into the soil and it will activate the water pump to pump water into the greenhouse if the moisture level is low. Results are gathered after 50 days as the duration needed for the plant to mature is approximately 40 to 50 days, as studied in one of the journals. The height and weight of scallions are taken. Height will be measured by a ruler. On the other hand, the weight will be measured by a weighing scale. There are two categories of weight, fresh weight and dry weight. Fresh weight is the weight of freshly cut onions while dry weight is the weight of oven-dried scallions. Plants have large amount of water in them. Hence, dry weight is more accurate as the weight measured is not affected by the amount of water supplied to it. That's all from me today. Thank you for listening and we have now reached the Q&A session of the presentation. Thank you.